Hello everyone. Today we will start our lesson in computer graphics about output primitives. In this picture we have points, line, circle, arc, ellipse, rectangles, polygons, curves, etc. Now the points. We all know a small and squared unit area in a short is known as point. In this computer graphics, point is the reference of the pixel. The pixel is the square shape and very small in size. In mathematical points x and y within an image, the area, here we have height into weight. Here we have small amount of boxes. Here these small boxes, each of the small boxes is known as a point. Scan conversion is the digitalize a picture and define it gives an application program into a set of pixels instead the values stored in the frame buffer. That means from the values in the frame buffer we can generate an image on the screen is known as the scan conversion or conversion. Point scan conversion functions. Set pixel xy is to draw a pixel at xy point in the grid, and get pixel needs to read the color of the value where the location is xy. The set pixel and get pixel are very important functions for our programming in computer graphics. Using the functions of C and C++. Here we have declared how to use those functions in C and C++. In set pixel, here we use the put pixel section, means to put the color where xy is the position and c is the color value, and get pixel here x and y is just the position. The range of c, here the range of c is from 0 to 15. That means here total 16 values. In this section we have that we started the value from 0 to the 15. Here altogether we have 16 colors. In here we include this function by graphics.h. If you include the graphics.h in your program, then only you can use these color functions. Now a line, you have already know what a line is. Here we have x coordinates and y coordinates. In first we have the value of x is 0 and y is 1, which looks at like this point. And in this point we have the value of x is 5 and y is 4. That is why we have 2 points, and in between them we need to draw the line. But if you can see, this line is not properly matching with the pixels or the blocks. Here it is in this line, but here we have partial in this line, and here we have partial points in this point. That is why if we draw the line with the help of the pixels, the line will looks like this. This pixel, then this pixel, then this one, and then lastly this one. It is not looking like a proper line. That's how a scan converted line looks like. It is difficult to determine whether the pixels are belonging in the object. That is why the lines in the pixel section looks like this. In scan conversation, we are using the direct application of line equation. In this section, we will apply the formula of how to draw the line in the given input codings. Here we have several methods like direct application of the equation, then digital differential analyzer, which is DDA, and lastly the Bresshenham line algorithm. In direct equation of line, we have the value of x1 y1, which is the first point, and x2 y2, which is the second point. The line equation is y equals to m plus m into x plus b. For applying this formula, we can draw through the line. Here we will first set the value of x is x1 and y is y1. Then increase the value x by 1 and compute the value of y with the equation, which is m plus x, m into x plus b. And lastly, draw the xy of this location. That is how we can draw this line. By these three steps, we draw this line in direct application of line equation. In direct equation of line, here we have some steps of the algorithms. That is how the line is drawing here. First, we need to draw the xy position and then use the color which is used by the put pixel, the value of xy and then the value of the color. Then step 3 and lastly the drawing steps. That is how this line is drawing. You can have a snap of this one. In the direct application of line equation, the diagram we use to draw will looks like this, and those steps we have already seen in our previous slides. Here, that's how we finally draw the line with our line equation. By the scan conversation, we can have some multiple points like this point, this point, this point, and this point by applying the formula of x and y. But those points are not in the manner of the line. That is how we use the next high state and then using the round. When you use the round, the values will looks like this, and if we use the high state, the values will looks like this. That's why we prefer to use the round values for direct application of line equation. From our next video, we will discuss about Digital Differentiation Analyzer or DDA. That's for today. Thank you.